Hello, Algebra 2. Here we are with 4.1, graphing quadratic functions. All right, a quadratic function is a function that has the greatest exponent of 2. All right, 2 is the biggest exponent in the function. And it will look like a u or a lowercase n or an upside down u, and those are called parabolas. Okay? Some tricks here for graphing. The vertex, which is either the top point or the bottom point, okay, that's a pretty important place to start. How do we get that? The x-coordinate of the vertex can be found by using x equals negative b divided by 2 times a, where it's ax squared plus bx plus c. So negative opposite of this number divided by 2 times that number. The y value for your vertex can be found by putting that x value back in. So I put the x value back in for the x's, and I see what the y value would be. Okay, so we got a little example problem here. Hopefully it's not too bad. Okay, find the vertex, the axis of symmetry, we'll talk about that, and the y-intercept. The y-intercept. Okay, we'll start by just getting the vertex. Okay. All right, we use x equals negative b over 2 times a. So we need to know what our b and our a are. Well, here it is, ax squared bx plus c. So my a is actually a 1. And my b is negative 4. All right, so if the b is already negative, when I put it in here, negative of negative 4 is going to end up being positive 4. 2 times 1. Negative of negative 4 is positive 4 over 2. Our x-coordinate's 2. Our x-coordinate of the vertex is 2. Now I put that 2, it's going to be 2 comma something. I put this 2 back into the original. X squared minus 4x plus 1. Okay, if I put 2 in here. Okay, 2 squared is 4, minus 4 times 2 is 8 plus 1. So 4 minus 8 is negative 4, plus 1 is negative 3. So x is 2, y is negative 3. My vertex is at the point 2 comma negative 3. Okay, so let's think about this. 2 comma negative 3, we're down here somewhere. Okay, it's going to be opening up. We'll talk about how I know that in a little bit. It's going to be kind of going like this. Something like that, okay? The axis of symmetry. Think about what symmetry is. Okay, you've probably talked about symmetry back in geometry. It's like a line. It's like a line that you can fold it over. So what would be a line that I could fold this over? Ta-da! Right down the middle. Okay, and that's always, for this chapter at least, that's always going to be x equals the x-coordinate from our vertex. Okay, because it goes through the vertex, that's the middle. And a vertical line is going to be x equals, so it's always going to be x equals the coordinate of our vertex. So x equals 2, the x-coordinate of our vertex. 2 comma negative 3, x equals 2. Sorry, x equals 2. So that's how we get the axis of symmetry. It's x equals the x-coordinate from vertex. All right, and the y-intercept. Okay, the y-intercept is where I cross the y-axis. Okay, what would be the x-coordinate for any number over here on the y-axis? 0. All these are going to be 0, something, 0, 1, 0, 2, 0, 3, 0, 4, 0, -1, 0, -2, 0, -3. So the y-axis is all going to be 0, some number. Okay, so how do I get the y-intercept from an equation? I put 0 in for all the x's. So for y-intercepts, we want to put 0 in for x. Okay, but we'll go the long way. How about that? We'll show all the work here. 0 squared minus 4 times 0 plus 1. 0, 0, 1. So my y-intercept, and I did a decent job of guessing. It looks almost like 0, 0, but we're a little bit up. And we're going to go through at 0, 1 for our y-intercept. Okay? So, find the vertex. Negative b over 2a gets me the x-coordinate of the vertex. Put the x-coordinate back in, get the y-coordinate. That's your vertex. That's the very, very top or the very, very bottom. It's the middle of your parabola. Axis of symmetry. Okay, for us right now, we're only going to be doing vertical ones, up and down. All right, they're either going to be opening up or opening down. We're not going to have any sideways ones. That's what we're doing in Algebra 2b right now. Okay, we're not going to have any sideways ones. All of ours are opening up or opening down. So it's always going to be x equals the x-coordinate from the vertex. And then the y-intercept, we put 0 in for all the x's, and that will give you your y-intercept. Next page. All right, now we actually have to graph it. Okay, so take a look at that. X squared plus 6x minus 2. All right, what's our y-intercept going to be? Remember what the trick is for y-intercept? Put 0 in for x. Zero squared is 0. 6 times 0 is 0. 0, 0, -2. My y-intercept should be 0, -2. Vertex. Remember, we're going to use this. X equals negative b over 2a. For now. We'll get a nicer way later on. Negative b, so it's going to be negative 6. All right, b is positive 6, so negative 6 over 2 times, my a is a 1. So we have negative 6 over 2, x equals negative 3. Now how do I get my y value? Negative 3 squared, put this one in, right? X squared, so negative 3 squared plus 6 times negative 3 minus 2. Uh-oh, I might have picked not a very good one. We'll see. Hopefully it works out. Y equals negative 3 squared is positive 9. 6 times negative 3 minus 18 minus 2. Looks like we're going to get negative 11. So not terrible, but it also isn't going to fit perfectly on the graph. We might have to go 1 off the edge. So my vertex is at negative 3, negative 11. Once we have our vertex, the axis of symmetry should be pretty easy. Always going to be for us this chapter, x equals the x-coordinate of the vertex, negative 3. All right, so let's put this down. We got negative 3, negative 11, All right, there's my vertex down there at -3, -11. All right, make a table and graph it. So for this first lesson, we want to make a table. What we want with a parabola, we want to try to have 5 points. We want to try to have 5 points. Okay? Sometimes on a quiz or a test, 5 just isn't going to fit on the graph, and then it's okay to have 3. The vertex and then 1 on each side. But for homework, we want to try to get 5 points on there. The vertex and 2 on each side. So what we should do, what I suggest here for at least the first lesson, is make an XY chart. All right, make sure we got 1, 2, 3, 4, 5. Yeah, we got at least 5 blanks. I might go 7 just to go a little extra. And you're going to put your vertex in the middle, -3, -11. Okay, and now we want to build a table around -3, -11. Okay, so we're going to fill in with -4, -5, -6, -2, -1, 0. Okay, now you can go through and substitute all those in, put -6 into your equation and get your answer, put -5 into your equation and get the answer. All right, here is just a little bit of a shortcut. Okay, we're going to go to y equals on our graph, on our graphing calculator. Okay, our equation was x squared. All right, how do you get x squared? All right, so here's x. And then for squared, you can just push the x squared button right there, squared. Okay, plus 6x minus 2. All right, graph. So we can kind of see a picture of it. It's going to look pretty close to this. We need to go just off the edge for our vertex. That's okay. All right, what I like to do for this is I like to do it this way because then I can still see the picture. Is I'm going to push trace. All right, and once see it's going to come up with these coordinates down here on the bottom. And now I can just type in -6, enter. Oh, -6 is -2. So I can still kind of see it on the graph, right? -6, -2. -5, enter. -5 is -7. -4, enter. -4 is -10. All right. Let's double check our vertex. -3, -11, yep. Okay, now remember what we said about axis of symmetry? All right, it's going to be this line right here that you can fold everything over. So as long as these gaps are the same, these are all 1 apart, and these are all 1 apart, you could just flip all those points over. All right, so -10, -7, -2. As long as all the gaps are the same all the way through. Okay, you can do that. Just if you don't trust that, you can certainly keep going through here. -2, enter. -1, enter. 0, enter. All right, there they all are. Another way to see these points, you can push second table. Second graph gets you to the table, and there everything is, 2. So some people like this because then they can just fill in their chart, right? You can use your arrows up and down to move it so that -311 is kind of in the middle. All right, and then we can just fill in the chart, fill it all in. I like going the other way because then I can still see the picture. Some people don't need that or don't like that. It doesn't matter. There's no wrong way to do that. If you don't have your graphing calculator on a particular day, you're going to have to do it the slow way and put them all in individually. All right, so let's finish graphing this out. So we have -4, -10, -5, -7, so this is 10, so 9, 8, 7. And then -6, -2. Okay, and then we can reflect these over. right, yep, 0, -2. That was our y-intercept. We had that earlier. All right, now we can try to smooth this out. Do the best you can there. Okay. What else can I tell you about this? Oh, we got to get our axis of symmetry that we had. X equals -3. Okay, this is a common thing people forget. We do the work up here for the axis of symmetry, and then we forget to put it in. Dotted line down the middle. My dotted line's not showing up very well. And then label what it is, x equals -3. Okay, and there we are. If it's nice points, guys, I don't mind if you don't actually label them. And then, especially if they're over here, like -6, -2 is right on the money right there. So we don't need to label it on the actual graph, especially with the table being so close to the graph. I can just zip over here and see what they're supposed to be. If it was a quiz or a test and you don't have a table immediately next to the graph and it's like some decimal point, like 3.21, 4.56, then you should probably have like a decimal next to it somewhere on there. All right. So we talked a little bit before about how I know it was going to open up or open down. Really easy way to tell. Positive x squared, the arrows go up at the end. Negative x squared, the arrows go down. Positive x squared, the arrows go up. Negative x squared, the arrows go down. All right, so if the arrows go up, my vertex would be the bottom, which would be the minimum point. If the arrows go down, my vertex is the top, and that would be the maximum or the highest that we get. Okay, so if they talk about minimum and maximum, it's exactly what you would think. Minimum is the lowest that it could be. Maximum is the highest that it ever gets. Okay, determine if the function has a maximum or a minimum. Find the value. State the domain in range. Okay, so it doesn't say we have to graph it or anything. We should still practice finding the vertex because that's going to be the key point here. The vertex is going to tell us a lot. All right, so x equals -b over 2 times a. So we got, here's my a, here's my b. So b is 10, so -10 over 2 times a is what this time? -1. So -10 divided by -2. My x-coordinate is +5. The y-coordinate is going to be -5 squared plus 10 times, not -5 squared, +5 squared plus 10, negative on the outside. There we go. I knew there was a negative. Plus 10 times 5 plus 30. So we have -25 plus 50 plus 30. Okay. 25 plus 30, 55. Double check that for me, guys. I might have made a mistake. That negative sign, misplacing that a couple times has me a little nervous. So I have 5, 55. Okay, now it's negative x squared, so I know it's going to look a little something like this. Okay, it's going to look a little something like that. So is this the high point or the low point? That's going to be the high point. Okay, so it's going to have a maximum. Now, when they talk about give the maximum or give the minimum, they're usually just talking about the y value. I don't care if you give me the full point, but I think the book's usually just going to be talking about the y value. So you could call this 555, or if you just want to say 55. Okay, now what does that mean for the domain and range? Okay, the domain, pretty easy for x squared, is always all real numbers. Okay, it's going to go forever left and right. Or if it's going up, it's going to go forever left and right as you go up. Now the range you got to think about. Okay, if we're at 55 and all of them go down, 55 is the maximum value. All right, that's the biggest it could be. So my range are all the y's that are less than or equal to 55. Okay. All right. And how can we do this on the calculator? There is some problems on here that you might need to be able to use your calculator to find. Let me find a good problem for you here. Lesson 4.1. We'll just pull this one right off the homework. We're down there in that bottom section. Okay. We'll just flip this over. And we'll use just one of these right off the homework here. 12x squared minus 21x plus 8. Y equals, all right, 12x squared minus 21x plus 8. So here we are. Can you see that? Okay. So, is this going to be a low point or a high point? Okay, my vertex is on the bottom, so that's going to be a low point. That's going to be a minimum. How do I find it from the calculator? We can go, now if this is a quiz or a test and it said show algebraically how to find the vertex, you're going to have the work. Okay, but if this just says use your calculator to find it, it's second trace, and we said that was a low point, so we're on the minimum. Left bound, right bound. This trips kids up every year. All right, so here's where I think it is. Let's scoot your little, I call him the Spider-Man, the spider, whatever you want to call this little thing, your cursor. Scoot him down to where you think it is, okay? Left bound. So you got to give like your calculator a wall on the left side. So we're going to hit left like 3 or 4 times. 1, 2, 3, 4. And then hit enter. And if you have this calculator, it puts the little wall up. All right, right bound. So go back to where you think it is. Right bound, click right 3 or 4 times. 1, 2, 3, 4. And it puts another line in there. So what it's doing is it's saying, we're looking for the smallest value between here and here. And it squeezes it in until it finds the smallest value. It says guess. We're going to tell it, start checking things down here. Delete, delete, delete. And here it is. Our minimum is at 0.875, comma, negative 1.1875. All right. That's how you can do that. And let's see, the directions in the book will tell you to round to a certain place, so it might be negative 1.19 there. But all right, and we can talk more about this in class if you have questions. So, all right, folks, there you go. So take a look. This video is being recorded in the wonderful year of 2020. So I think we have it split up. 19 through 31 odd for day 1, and then 32 through 48 even. If this is a different year, these could both be back together on the same lesson. Thanks for watching, guys. Good luck.